All right, this is gonna be a different video than other videos. It's actually more set to be an assignment prep, and it's my usual lecture that I do for this chapter. I'm assuming that you've watched as many videos as you can on hash tables, and that you've read the book and you understand what hashing is. The one thing I do want to add is that essentially this whole course is all about teaching you how not to do things before, at the very end, when we learn binary trees, that teaches you how to do things. So memory management, such as linked list arrays, have their good parts and the bad parts. The parts that are good about arrays are that it's fast, quick memory. However, you can't just add one at a time. The things that are good about linked lists are you can add as much as you want on demand. However, as far as memory is concerned, it's slower. You have to go through every link before you can get to a specific node, and it is not efficient, but you can add one more or one at a time. Now then we get into, okay, here's the first, before binary trees, here's the first next development, which was called hash tables, meaning that we're going to use arrays, and we're going to use an array of a set limit as far as size, but we're going to store the data based on what the data is. So it's going to go through an algorithm where it takes some of the data that you're storing, such as an object, and it takes the values or what is inside the data and converts it to basically represent an array index. And that array index that it comes up with is where the data is stored in the array. So in other words, it makes up for an array's lack, or it allows for the array's efficiency even faster. It still lacks the ability to add one more. However, for certain things, a huge hash table is okay as long as the memory is ready to go. But the problem that hash tables have is amount of the robustness of a hash table. Essentially, a hash table has an issue where some data or two pieces or two objects that you want to store will essentially evaluate to having the same index to store it in the array, and that's what's called a collision. And the way that a hash table handles collisions is what makes it separate from other hash tables. So it used to be a big thing to come up with awesome hash tables that worked really well until Google and binary trees changed the world. So when we get to binary trees and discussing it, that is truly the best way of storing data. Apart from arrays, linked lists, and we're talking about data, huge amounts of data. If it's small amounts of data that are limited, hash table is the way to go. Very limited, just use an array. Linked lists have their uses, but again, they're inefficient. If you need data, large amounts of data, on hand, quickly accessible, the binary tree is the way to go. But before that, we had hash tables. So that's going to be what we're going to look in today for the assignment. I'm assuming you know what a hash table is at the very lowest level. And this is going to be an assignment walkthrough, and it's going to just set you up for being able to complete your assignment. So the first thing that you need to do for this assignment for building a hash table for the state data is you need to get the student program files. And in the student program files, you'll find the skeleton of the beginning of your code for your assignment. So I've just downloaded the student program files and zipped it, and I'm going to go into the source code and what chapter are we in? I'm going to take it just a gander. I think it's right around here. Actually, yeah, we're close. There we go. There's hashing here. This is going to be the hash T program that you're going to take. So we're going to actually create a project that we're going to take this code. It's going to be just this hashing code right here. This is what you're going to actually use, is the hash t.h. And we're going to implement that and finish that that assignment so that you can add states in the data. And I'm going to basically give you more of the skeleton, and then it's going to be up to you to finish on your own. So here is where we're going to start a project. I have actually a project I got to close down here. Okay. Okay, so we're going to call this state hash. And I'm going to take that hash t and the CPP file, and I'm going to add it to this project that I just created. So I'm going to go back to the source code. I probably already have this window open somewhere. Hashing, grab this code. And we're going to go to that folder. Getting quite a few folders. About time to do some cleanup. State hash, here we go. Here's where my project is. I'm going to put the state hash info in there. And now I'm going to add it, but before I add it, I'm going to rename this main, and I'm going to name this main.cpp. And we're going to begin here. So you're going to have your hash t.h and the main CPP file that came with. Add it to your recently created empty project of existing items. And we're going to say add. Now there's a lot of this stuff that you're going to have to finish on your own. You're going to actually have to create a state object that you will use to put in your hash table. But there's things that you have to finish in this hash table. One of that is the insert, which is actually given in your book. And with that insert function comes another function in your book, which is the quadratic probing example. So also you need to create an array index list. So there's going to be a few things that you need to complete this. Now I'm going to go a certain distance, and then I'm going to let you guys finish it up. So let's go ahead and get started. This is the insert from your book. What we're going to want to do is make it so that we can create a state object and put that into the list. So I'm going to go ahead and go to the assignment from your book, and we're going to look at the portion of the insert function that is not here, and that is the key generator. The key generation, I believe this is the quadratic probing right here. It's all done for you. So don't get too cross-eyed when you look at that in the assignment. It's the quadratic probing is already done. And that's just a fancy name for choosing spots in the hash table in a certain method so that it reduces collisions. So don't, let it be. Even I don't like the way they call that quadratic probing. So the insert function is done. There are some overloads that you're going to need to add for your state object. And those overloads that you're going to need to do are going to be the double equals overload. You're going to have to tell it how to compare two state objects. So let's look at the assignment. I believe we actually have to create a state object as part of the assignment. I believe I have this. Nope, that's tutoring. I have it somewhere in here. Vital source. Oh, it's a web page. Let's see. Yep, I'm recording 9 minutes in. Let's get moving along a little bit faster. Here we go. Here is your assignment on page 530. So you're going to be creating a, it's number 7. So you're going to do the class state data. And then you're going to have to do some overloads in that. Now in the state data class, I believe you're going to need to put a string in there. And let's see, what else are you going to need? Using quadratic, that's already done. Quadratic probing is already in the insert function. Test various hashing of some of the truths, named capital, area, year of emission to the union. Okay, so that's what we need for our state data class, is the capital, area, year of emission, and the order of emission. You know what? The only one that really matters here is the name and capital. The other ones, the name and the name is actually what we're going to do the hashing on. So that's the one that makes the most importance. And it looks like they are using a static case of the name, and they're using name all lowercase, so they're actually counting up the ASCII values of the name in the hash table to come up with the index of where it's going to be stored. And then they modulate it by the hash table size, so that no matter whatever they come up with as they're adding up the ASCII values of each character in the name, it's going to be within the size of the created table. So you're going to be setting the hash table size also, which is going to be 1,000. But to test everything and making sure everything's working, you might want to start with an HT size of 5 to 10. And that can test your collision handling and stuff like that. So let's go ahead and get started on this. Let's see. This is the hash function you need to add to the actual hash code. So I'm just going to copy this, and we're going to bring it over here to our hash, and we're going to add it in as, and I'm going to go in line with this. I hate this separating things out. Okay, so that's our inline hash function. That didn't look like it formatted too well. So let's go and look at it and compare. That looks like it didn't do very well at all for... Okay, well, you know what? A trick for this, sometimes you can get it into Notepad. And it'll actually do some of the fixing for you. Sometimes it all becomes one line. That doesn't work. Word actually helps too sometimes. That's a little bit better, but not as well. Okay, well, heck with that. I guess it's not working. We're going to have to actually fix it, I guess. Do it the longhand way. And you got to fix it in a way where you know that there are no ghosts. So you got to get rid of all the white space. And I think that what we had before was better. Okay, so... Oh, wow. That is messed up. I'm going to pause it for a little bit and see if I can't get that copied as text from a lot of people just type it in, actually that's probably what I'm going to end up doing. Okay, well, let's just, the heck with it. Let's just type it in. That way we know we're not having any ghosts or anything. And what I mean by ghosts is whenever you copy something, you see that blank is coming out right here. That was a ghost right there. So whenever you delete empty space from a copy paste, you can have characters that are not showing up in the editor. So I'm just making sure that I delete all the white space that came in that I know could be an issue. Okay, so this is the hash function. What this is going to do is it's actually going to take the name of your state and give it a key, and that's what you send into this. The insert function, the name or the key that the hash function came up from the name on where it's going to be placed in the array, and then the record that it's going to put in. Now remember, this is all templated. So we're going to actually have to overload the equals operators and some of the other things to get all this stuff in here working correctly. Okay, so let's go ahead and get to the typing here. I'm going to go ahead and minimize and get things so that I can kind of see it. Here we go. Int I, sum, int len, I equals 0, sum equals 0, len equals name dot length. For int k equals 0, k is less than 15, minus len. Yeah, they got their little hashing algorithm here that they must be fairly proud of. Okay, so this is what you're going to use to actually crunch down this each state's name to come up with the index that it's actually going to be placed into for the hash table, which is just an array. Oh, that's 5 k plus plus. Now make sure it's might be an issue where I have to come back. Sometimes I've not done the best jobs typing this stuff in. But that's what debuggers are for. And if you haven't started using them now, good luck. And I'm not going to use the static cast. I hate the static cast. I'm going to use the old school. Okay, so they put in some mathematical, and it's going to be in multiples of 4 because they're using quadratic probing, and don't spend time on it, learning it. It is old school technology. Hash tables should never be used anymore for large sums of data. That's what binary trees are for. Okay. All right, so this actually gets added to the cast of the next index of name, but multiplied by 128 again. Oh, ridiculous. Plus another cast of name, taking the name of, oh, that's not the right cast. An int with the name of I plus 2. So I'm just kind of going down here and just writing this stuff in. This is all one line, so I'm putting it all in one line right there. I plus 2, close it, semicolon. Okay, looks like that's done. Okay. Okay, now it's going to be I is equal to I plus 3. Okay, so they count up every third one in oh, it looks like they just go to the first 5 characters. Now that's ridiculous. Oh, they increased the length of name to 15 characters using blank spaces. Oh, so it looks like they make every state's name somewhat unified, other than the characters in the first 5 themselves. Okay, so that's the hashing function. Now this is the really important part. When you say return the sum, but modulate it by the HT size. So let's say that the HT size was 10. That's the hash table size. So that means no matter what happens in here, they have to find a place to put that state based on its name, hashing to an index or a key that's between 0 and 9 in value. So this can only be a 0 to a 9 value, and that's where that state will actually be pushed in the array or the hash table that's the size of 10. And that's what the modulus operator does. It just says, hey, what's the hash table size? Make sure that whatever we calculate for a key or an index of where this data is going to go in our array, that it's within the size of the array itself. So that's our hash function. Now, ht_size is actually part of the hash table. Now, you notice here that size equals 101. That's going to be ht_size. So this constructor, if you do not send it the hash table size of any kind of value, if you send it nothing, it's going to automatically set the hash table array to 100 items, 101 items, 0 to 100. So when you actually instantiate a hash t object, you're going to have to finish this search. You're going to have to finish this guy, the retrieve, the remove, the print, and here is this guy, size. So this is where we will do literally this one. This is actually really simple, but you're going to have to do a few things. You're going to have to say ht_size equals size. You're also going to have to generate two arrays, one for the hash table and one for the index status list. Because this is what handles that tells you whether an index in the hash table is filled or not. So you have the array for the hash table, and then you have an array that coincides with the hash table to tell you whether that actual element or item in the hash table data has been put there. So these are two things that you have to actually create. The number of items in hash table, this is going to be how many items that are set as true in the status list. So the size is how big the array is. The length is how many items are in the array. And the status list is an array that indicates within the size of the arrays whether the particular element is taken up. So we are going to instantiate this. Length will only be increased whenever we do an insert. So this is going to be where we instantiate the H table and the index status list. So the index status list needs to be a new integer. Of ht_size. Okay, and the hash table is going to be a new element type. Remember, this is your T. This is your template T. We're going to be sending it states though, so this will be a new state of ht_size. Now, to be responsible, we are going to finish this, and we're going to say delete index status list in the deconstructor and delete the H table in the destructor. Okay, so those are two that I finished for you. So I don't think there's any more steps that need to happen in the constructor or the deconstructor. So basically, we're creating the table. That's what we're doing. That's so now, and then we delete the table. So we have our hashing function. We can go back to looking at this full on. So now we have our hashing function for inserting items in the list that then we will use then we'll run the insert for that. So this insert actually, you got to do the hash function before you insert. You could actually change this code, but we'll just run it from main in that manner. So let's actually create the state the state data. So we're going to go here to project add class. And this is going to be state data. Is that what they called it in the assignment? What do they call it? State data. Okay. And we're going to make it inline. So we're not going to do a CPP file. You know I love my inline. Okay, so you know what? I don't want to make all kinds of accessors, but the only accessors we need are for the name. So I'll make those. So string, name, and you know what? I think that I'm going to add some things here. Okay. And maybe just throw in string.h just in case. Okay. What are the other things that we need? We need capital. Okay, and you guys add the others here. Okay, because I'm just going to show you the hashing function. The other stuff you can add. Okay, so the name we need to have a get and set for the name. So we're going to say void set name, string name. We're going to say this name equals name. And then we're going to say string get name, return name. Okay, done. Okay, so that's all we pretty much need for state data. However, you're going to have to overload at least the equals operator here. So that means you're going to do something like, well, the equals operator is binary, so it's going to return true. So it's going to be operator equals, and then you're going to send it the other operator, state data other, and you're going, oops. And what you're going to do is you're going to compare this data. So you're going to do, is it string compare? Or can we use less than or greater than with strings in C++? I think we can do if this name equals other dot name, return true. Otherwise, return false. Oh, hey, that worked. Okay, I give you that one. That's enough of me doing work for you. So now let's go back. We got our state data. Let's go to main. And, let's put a constructor in there. Let's put a constructor in there so that we can instantiate a state and just send its name. You'll add more arguments. We're just going to do name because that's all that we're hashing. And I want you to complete this this actual object with all the other variables that are in the assignment. So what we'll do is just to make it easy to throw or create states, we're going to just throw in a quick constructor, overloaded constructor, and if we're doing an overloaded, we probably should do a default. Okay, we're good. Okay, so now we can actually create states. So we're going to go here to main, and we're going to include state data. And I'm going to say state data 1 WA Washington, state data You know, this is getting ridiculous. Maybe we should do a vector or something. I don't know. Texas. Let's see how many states I can do. Let's do the ones that we are around us. Okay, that's enough for now. Okay, now, and then we're going to also create a hash t. So we're going to do hash t state data. We're sending it state data. That's what's going to be for the data type. This is what element type is going to be in the hash table. And we're going to call it my table. Okay, so we're going to do my table dot hash function. Okay, let's get the hash function of Washington dot get name. Okay, and then let's take that value and do a my table dot insert based on the hash and the actual record that we want to be inserted. Okay, so this right here, this for the insert function of the hash table, we need to send it a key, which the hash function generates. Then we insert it based on the generated hash function, and we send the record that we want to store. So you see here that we have generated the key for the insert based on the hash function. This hash function you can actually put up here in main if this is driving you nuts. You can put it whatever you want. But I just put it in the class, so we're just running it inside the class with the argument that to hash the name, and whatever index that returns at, that's where we're going to be putting our state. So, but we also need to make sure that we create a table, but let's make sure that it's size of like 5. Size of 5. Yours is going to be like 1,000, but 5 will help us determine collisions that happen. So I'm going to go ahead and duplicate this. We got 4. So we're going to do text here. Oregon and Idaho. Okay, so let's just look at what happens. I'm going to set a breakpoint here. The first thing we do when this happens is the hash function is going to run. Oh, well, maybe the first thing is it's not going to compile. Okay, let's go fix some things. The insert function, I don't like you. Go away. Let's bring that down here. Insert function. Just make it inline. Although it should have worked. That shouldn't have been a problem. That's totally fine. That should have. Maybe something else is wrong. Maybe I should look into what else could be wrong. Oh well, of course, it's my fast typing. You know what? Let's just Control Z that back. And fix my typing. My typing is, the error is right here. This is what I typed in fast from the book. Oh, I'm pretty sure I know what it is. It's because I changed that static cast. Yeah, I need an open parenthesis here. Okay, so this is the does not equal. This is the error you're going to come up with, because what it's saying is you're trying to take an element that's state data and trying to compare it to another state data element. because this, remember, this element type is a type T for the not equals. So we got to go back over here to state data, and we got to take our equals and make this a not equals also. So maybe I'm doing a little bit too much here for you, but this will get you at least started. I think for you guys to finish the search functions, I believe you need to finish, but that gets us actually running, so we're good. Okay, so that means we're able to run a hash on this hash function, hash the data, and then also come up with a key. Okay, so let's look at it. All right, insert. I'm going to do a step into, and it's going to take us into, well, of course, the getters. Okay, I know another step into. Now, here we go. Here's where we take the name Washington, and it's going to hash that name, and it's going to return that name. So I'm just going to set a breakpoint here and hit play to continue all the way down there. Now, the sum is this huge 7,900 and blah, blah, blah that they've somehow calculated from the ASCII values of each character's name, multiplying it by this bunch of numbers, and it's just stupid ridiculous. So what it's doing then is it's going to take that and not modulate it by the size, which is 5. So it's going to bring us into a number between 0 and 4. So if we add a watch there, we'll see that that the value is 0. So it's going to store this first one in the index 0 of the hash table. So it's going to come back, and we're saying insert, and this evaluates as 0. Did I select? Oh, I selected too much. Okay, so it evaluates as 0 here. So this comes down to 0, and it's going to send it in. So let's do a step into. Okay, so our hash index is 0, that our hash function. Our record for Washington is going in, and it's going to use this quadratic probing to throw it into the list. But notice here that it also says where it's throwing. So let's set a breakpoint, or let's set a watch for the index list. Okay, and let's set a breakpoint or a watch for the hash table. Okay, now let's do I'm going to go ahead and run it all the way down to here. And then let's look at what this hash table and index status list is. Okay, so we look at the hash table, and you see that it put Washington in the first position of the hash table. And the index status list, you'll see that the first element or the first part in the array, actually let's do this differently. Let's look, you know what I didn't do is I didn't, it's not showing us the indexes here. That this is being assigned to what index. So the size, oh, that modulated as 2. Interesting. Okay. If we looked at the hash table, we would see that the first item in there at location 0 is Washington Capital. So essentially, let's look at it this way. This is the H table. And it is an array of 5 items. This is the index status list. And it's an array of 5.